In this video we're going to look at the Unicode XSS lab. So I'll start by launching the lab and trying a basic attack. And it looks like that's been escaped, and if we view the source we can see that these characters have been escaped. Okay. Now I'm on the Wikipedia page here for half-width and full-width forms. So there's a Unicode block that contains various things, but part of it is full-width forms of the standard ASCII characters. And you can see here we've got full-width less than sign. Okay, so let's try replacing the regular with the full width. Right, and that's surprising because we've been able to inject a tag. Now, just to be clear, the browser does not interpret full width less than and greater than signs, or it doesn't interpret them as HTML tags, it just displays them. So what's happening? Well, if we look in the source, we can see that they've been converted to regular less than and greater than signs. I'm just going to, just for completeness, I'm just going to go back to the very first lab, basic reflective XSS. And if we try the payload in here, we can see in this scenario the full width less than and greater than are reflected as they are. The browser has just displayed them, it's not interpreted them as a tag. And yeah, we can see that in the source code as well. Okay. So, what's going on? So, there are 4 forms of Unicode normalization, and this is a way to try and deal with the fact that there can be multiple ways to deal with a single glyph. So, for example, if we consider a letter like A with an acute accent, there is a Unicode character A with acute accent. There is also a Unicode character A, and separately a Unicode combining character for acute accent. So there's multiple ways that you can encode a particular glyph, and that can be problematic for computers in various ways. So the idea of these normalization forms is to help deal with that. So NFD is decomposition, and NFC is composition. So NFD would take the A with acute accent and break it up into a separate character and combining character, and NFC would do the opposite. Now, there are also compatibility forms of each of these. Now, I'm not quite sure from the responses I've seen if this lab is doing NFKD or NFKC, but it doesn't really matter. What's happening is it's doing a compatibility transformation, and that means that the full width less than and greater than signs are converted to regular less than and greater signs. And there's a crucial detail here about the order that it does this, because what we can infer is that the lab is first of all doing the HTML sanitization and then doing the Unicode compatibility normalization. If it did it the other way round, what would happen is the less than and greater than would be converted to standard forms, and then second they'd be sanitized as normal. Okay, so that's what we can infer is going on under the hood. Let's try executing our payload. And there we go. Okay, so just to be sure, let's take this URL. Let's paste it in. And there we go. We've successfully solved the lab. Now, you may be wondering, how realistic is this? Does this actually occur in practice? And while it's not particularly common, it does occur in practice. And one scenario that I've seen this is with MS SQL Server. If you have a varchar, which is a non-Unicode type, if you try and insert a Unicode string into a varchar column, then it will do a compatibility normalization, and that can have the effect that we've seen, that the full width forms are converted into their regular forms. I believe this can also happen with IIS if it's outputting to a non-Unicode code page. And in general, the solution to Unicode issues like this is to have the full application work in Unicode all the way through, and that tends to work around these kind of issues.